Hi, pre-calculus students, and welcome to one final video for this year, a little real-time midterm review action. All right, so I kind of hand-selected a bunch of problems I think would be beneficial for you to see, live instead of just looking at the answer key on Blackboard. All right, first one, number 5, you're asked for the domain of this and also the whether the function is one-to-one. All right, so for a square root function, the domain is based on what's under the square root. So if you just, for the domain, because it's square root, if you just set what's under the square root to be greater than or equal to 0 and solve that equation, you'll have your domain. All right, because in math, in order to graph on a real number system, we have to make sure that what's under the square root is not a negative number, because then we have an imaginary term. All right, so if you force that expression to be non-negative and just adding x, we're finished. That's the domain. Okay, this means x is less than or equal to 14. Or you can write this as, if x is less than or equal to 14, the domain could be written negative infinity up to 14. Of course, you could also consider the graph of this, and then go from the graph. You could even graph this in your calculator if you wanted to, and then kind of zoom out and just check, see the way the graph looks. That's fine. Or check the table on the calculator. But doing it by hand, I wanted to show you also. All right, so this is going to be the domain. It's a multiple choice question, so you have to be familiar with both of these. But we've kind of focused on intervals, so look out for that kind of notation. All right, is the function one-to-one? Yes, all square root functions are one-to-one. Remember, a one-to-one function is one that is a function whose inverse is also a function. All right, the inverse of this also must be a function. The quick way to figure out if a function is one-to-one is by drawing a horizontal line on the graph. If it hits more than once, the function is not one-to-one. So in this one, you do kind of want to consider the graph. I would recommend, is the function one-to-one? Just draw the graph itself, and then imagine a horizontal line going through the graph. If it hits more than once, it's not one-to-one. This graph looks like this. I mean, whether you do it on the calculator or by hand, it's the square root function, then reflected over the x-axis and over the y-axis, and shifted 14 to the right and 7 up. So it's like there, that endpoint's going to be 14, 7, and it's going to go like this. So that's going to be the graph. Yes, this is one-to-one. Right? A horizontal line would only hit one time. So you don't need to do this by hand. You can do it on the calculator, but one-to-one function passes the horizontal line test. So yes, it is one-to-one. All right, let's skip over to, problem 8. Very quick problem, but I wanted to mention it anyway because it's an easy one. I want to make sure you remember how to do this. So give the range of that function. So that one, you could, again, do in your calculator, but that just takes up time. So this is an easy enough problem you should be able to do by hand. So the range of that, so f of x is negative 10 times x minus 3 squared plus 93. The range is all based on, this is a quadratic function, it's based on the direction the parabola opens, up or down, and the y value of the vertex. So the y value of the vertex is 93. This graph is shifted 3 to the right, 93 up. So that's the vertex, 393. And it opens down, right? It's 10 times narrower than the parent function. That doesn't really matter in this problem. But it looks like this. Right? That's more or less the way this graph's going to look. The range we can get from the graph is negative infinity up until 93. Right? And this only is based on the fact that it opens downwards. So the vertex is a maximum point, right? 93 being the maximum value for y. And negative infinity is where we start. Right? Always goes low to high. Make sure your notation is correct, even though it's multiple choice. So you probably could get away with that. In a free response question, make sure your notation is appropriate. With intervals, we always go lower to higher. So that's the number 8. Number 11, that's another easy one. I want to make sure you guys can handle it. Number 11 says, sorry. If negative 5 is a root of this, p of x, p of x is 3x squared, kx, and 5. If negative 5 is a root, find the value of k. So if you're given negative 5 as a root, what a root is an x value that makes the polynomial equal to 0, as you know. So if we plug in negative 5 for x, then this whole polynomial has got to equal 0. If you're told negative 5 is a root, in other words, that's saying that negative 5, 0 is going to be a point on your function. Right? Negative 5 is a root. Plug in negative 5 for x and 0 for y, right? Make the function equal to 0. and just solve this equation for k. Right? This is 25 times 3 is 75, plus 5 is 80. 80 minus 5k equals 0. So 5k equals 80, right? Just moving the 5k over here, adding it over here, and then k. K equals 16. So the answer is 16. All right, number 14. This is a challenging problem, but we've done several like this year. So I wanted to go over this with you one last time. You guys did a very nice job in this unit on exponents. Okay. So this problem involves several properties of exponents. And as I said in the unit on this stuff, there's many ways you could go about doing this. Okay, my way is just one way. But I'm showing you what I think is the most efficient way to do the problem. So one thing you could do, you could distribute this expression to both of these and go from there. I would recommend, though, first just dividing 3x to the negative first by negative 1x to the negative second, right? This is like a negative 1 here, right? So I would do this divided by this first, and then that result I would distribute. That's how I would do it personally. You could also distribute this to these two and go from there, right? So either way, I'm going to choose to divide these first. Right? So sort of looking at the problem like this. You don't need to show necessarily this step, but I'm kind of doing that, and then whatever that is, I'm going to distribute to this. Kind of take that back. You do want to show work. You want to show every step here. Right? This problem does seem to correspond with the multiple choice section, but I'm telling you right now, this problem, you will need to show work. This is going to be a free response question. So I think that's actually kind of misleading that this problem is in the multiple choice section of the review. This is a several step, multi-step problem. That's going to be a free response question. Right? 3 divided by negative 1 is negative 3. And then with the exponents, you can think about that many ways. But it's just going to be x to the first. Right? Hold on 1 second. A student is here to take a test. I apologize. All right. That happens. Anyway, as I was saying, it doesn't matter how you do this, but you could use subtraction, right? Negative 1 minus negative 2 is negative 1 plus 2, which is 1. So it's x to the first that way. You could also, remember there's a trick with any factor with a negative power. You could switch sides, right? So x to the negative first could become x to the first on the bottom. X to the negative second could become x to the second on the top. The risky thing about doing it that way is that sometimes, and I've seen people make mistakes already this year on this, is that they want to move the 3 also with the x to the bottom, right? The coefficient is separate from the variables. So if you're going to start moving stuff around, be very careful. Only move around the factors that have a negative power. 3 is just 3 to the first. It's by itself. X to the negative first. That alone can become x to the first on the bottom. But don't move the 3. Right? I think it's safer just to do negative 1 minus negative 2. Right? Now, we have to do some distributing. And be careful because when you're multiplying with exponents, you're really adding the exponents, not multiplying them. So be careful. This is like x to the first, right? I'm going to put in the 1 there, even though it's not really typically written. Negative 3, now we distribute. Negative 3 times 2 is negative 6. Here's why I put in the 1. Because we're adding 1 plus 1/4, right? We're multiplying x to the first times x to the 1/4. We add the exponents. We don't multiply them. So 1 plus 1/4, 4/4 plus 1/4 is 5/4, right? Now, negative 3 times really negative 1, right? This is really a negative 1. Negative 3 times negative 1 is positive 3. 1 plus, again, plus negative 1/4 is 3/4. So 3x to the 3/4, right? That's going to be the answer, right? So that's the way I would recommend doing this kind of problem. And the problem on the exam is very similar to that one. Okay, looking at problem 19 now. All right, so this is one that, because that is going to be a multiple choice question, number 19, you could theoretically, you're asked to give the equation of that function, right? And you're given a graph. So you could just go ahead and graph each one of the answer choices until you get the one that matches the, the graph there. But that just eats up time. So I do recommend knowing how to do this without necessarily using the calculator. All right, so we have there's clearly a double root at -2 and then a regular old single root at 0. So this graph, remember that when you have a point of tangency, this is the way the graph looks, right? More or less. This here, the graph, it decreases until it hits that point at -2, and then it increases again. It doesn't just go right through -2. It changes direction at -2. That's called a point of tangency, and to remind you guys, that's a double root. So we've got a double root at -2. So the roots here, roots, or zeros, -2 is a double root, and 0 is just a regular old root. So it says, give the equation of the cubic graph shown. So we have 3 roots, -2 being a double root and 0 being a regular root. So now you're going backward to write the equation, right? If -2 is a root, x plus 2 is a factor. Y equals x plus 2 twice, right, or x plus 2 squared, times, if 0 is a root, x is a factor, right? So just times x, usually put, in that in the front. So this is it. That's going to be your equation, okay? Maybe this graph got a little more narrow or something than the parent graph, so maybe there would be a coefficient in front other than 1, but it's not going to be a tricky question like that, okay? It's going to be, this really is just testing your knowledge of what the graph looks like and how, what a double root looks like, what a single root looks like, and then translating the individual roots into factors, all right? So that's going to be the answer, but again, worst comes to worst, you can always graph this, all right? And it's actually not the answer. I realized I made a mistake. This is a negative cubic, right? We go high to low, all right? High to low, like y equals -x, right? That's also a negative odd function. It goes high to low. So it's going to be a negative in front. I realized that immediately. I'm trying to rush to get through this before the end of this set, all right? So no excuses. I should have gotten that right the first time. Anyway, it's -x times x plus 2 squared. All right? You can use technology if you're stuck on that. Number 21 I'm skipping to. Find all the roots of that. And it's multiple choice. You could just plug into the equation from the choices, but that's not going to be a real efficient way to do it. So 21, all roots of this, x to the 4th minus 12x squared minus 64 equals 0. So if it's a trinomial like this, chances are it's going to factor. And because there's just a 1 in front, we can just use that old algebra trick, find 2 numbers that multiply to this and add to that. A little bit tricky with 64, but 16 times 4 is 64, and that can make the 12 also. So we have x squared minus 16, x squared plus 4 is how this would factor, all right? And x squared minus 16, that's still a difference of squares, x plus 4x minus 4. All right, so this, you have to still factor that, and this one is just x squared plus 4. That can't be factored further, right? This is prime. The sum of squares cannot be factored. And now we know our roots, -4, +4, plus or minus 4. And for this one, maybe that's not so obvious, so show some work. As we did in this unit back in September, anytime you had to solve a quadratic, I did expect you guys to show work. So here we would subtract 4 and square root. Don't forget plus or minus. And remember that the square root of 4 is 2, so the square root of -4 is 2i. All right? And remember that imaginary roots always come in pairs. Imaginary or irrational roots always come in pairs. So if you forgot the plus or minus, just remember, 2i would never be by itself. If 2i is a root, -2i must also be a root. So these are the answers. Alternatively, you could have used synthetic division with this. You would have found 4 or -4 as a root on your calculator and done synthetic division. But be careful. Make sure if you're using synthetic division to include a 0 for x cubed and a 0 for x. And that also is going to take you longer doing it that way. Factoring is always going to be fastest. Right? What do I have next? Number 22. This is a little technology review for you. Volume of a box, V of x, equals, we're in 14 minutes, getting a little long, but this is for your own good. Okay, so there's the equation of the volume, and we have to get out a graphing calculator to find the maximum. Let me see if I can find one yet. All right, so we can get this ready. But first we should probably graph this, because graphing is going to be helpful because you have to do the whole left bound and right bound business in the calculator, and usually the numbers I suggest you plug in for left and right bound are 2 of the roots. So we have 0 as a root, we have 6, and we have 2, right? So 0, 2, and 6 are your 3 roots. And this is going to be a positive cubic, right? Positive because negative times negative, positive times positive is positive. Positive cubic is going to start low, end up high. So the graph's going to be like this. We're talking about volume of a box. So it's really only between 0 and 2 that we're looking. Right? So the domain here is going to be between 0 and 2. But that doesn't mean that the maximum happens at exactly 1, right? Because cubics are not symmetrical like quadratics are. All right? So the maximum is not going to happen at 1. It's going to happen somewhere around 1, though. Maybe like somewhere between like a half and 1.5, somewhere in there. To find that point, we need a calculator. Right? So I'm going to type in the volume function in y equals, right? Just going to type in x times 12 minus 2x times 4 minus 2x, right? So I've done that. And now I'm going to hit second trace, calculate, and the fourth choice, maximum, that one. And now it's going to slowly graph the function, which is not going to be so pretty, but that's kind of why it's one of the benefits of graphing it on your own, because it lets you see the graph a little more clearly. And then it says left bound, right? Left bound, I'm going to type in 0. We want to find out that maximum point. So it's asking us for an x value to the left of that x value. We don't know that x value, but we know that 0 is obviously left of it. So I'll hit 0, enter. Right bound, I'll hit 2, enter. And then it just says guess, hit enter again, and you get that. All right, that's your ordered pair. The y value is the volume, right? This is a volume function, so y is volume. So we have 20.196. It depends, it's multiple choice, right? It depends how the rounding is done, but the maximum volume is going to be approximately 20.196, cubic units, right? The x value is about 0.9. So as I said, it's somewhere around 1, but not quite exactly 1. All right, that's a little reminder of the technology piece. Let's jump down to the free response. Okay, free response problem number 1. Tell you what, let's cut off this video now because it's already 17 minutes long. So that's kind of a review of the multiple choice section. In fact, let's do one more, but I'll make another video for the free response section, all right? One more that we did go over this in class, but I want to review this again, okay? So it says this equation has symmetry in which one of the following, all right? So it's going to be way too complicated to try to graph this function, or this equation on your graphing calculator because it's not written in explicit form. It's not in y equals form. And getting this in y equals form is extremely confusing. And this is not even going to be a function, it turns out, all right? So really what's expected of you guys now, if it says it has symmetry over which of the following, well, the x-axis, if it has symmetry over the x-axis, then plugging in, so to check for symmetry, so symmetry tests over the x-axis, you would plug in negative y instead of y, and you would see if this equation ends up being the exact same thing as the original, all right? So just test symmetry over x, you plug in negative y instead of y, and just see if you get the same equation. So if we simplify this, we could negative y squared is y squared, and this is plus y, right? This is not the same as this one. So this does not have symmetry over the x-axis, but it does have symmetry over the y-axis because if we plug in negative x instead of x, the absolute value of negative x is going to be the same as the absolute value of x, right? The absolute value of something and the absolute value of its opposite would always be the same thing, right? Like the absolute value of negative 5, the absolute value of 5, both of them are 5. So these are the same. This could also be written like this, right? So we do get the same equation. So there is symmetry over y, all right? Long story short, the usual suspects to have symmetry are the absolute value terms and the quadratic terms, right? Because if you square a term, whether it's negative or positive, you get the same thing. Take the absolute value of something, whether it's negative or positive, you get the same thing, all right? So those individual terms would be the same as the original problem, all right? So just looking at the equation originally, I could have told you it's going to have symmetry over y because if we plug in negative x for x, we will get the exact same equation, right? So there is symmetry over the y-axis. All right, so that's all for this video. I'll make another one later for